Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today I will be doing this chapter called as scalars and vectors. Now we have already done some part of scalars and vectors. We'll just recap that before we move ahead. First, what is polygon law of vectors? I had explained this to you last lecture, polygon law of vectors. I had explained this to you in the last lecture. Suppose if I have to add multiple number of vectors, right? Then I add them using polygon law of vectors. Suppose if I have vectors say q1, q2, q3 and q4 and I want to add them. What we do is, first let's draw the vector q1. Connect the end point of q1 to the starting point of q2. So this is q2, right? In order to find the resultant, join the starting point of q1 to the end point of q2. That makes a triangle. So this is going to be my q1 plus q2. Now to the end point of q1, this is the starting point, this is the end point, connect q3. Join this. This will be q1 plus q2 plus q3, right? To the end point of this, connect q4. This is my q4. Join this. This is going to be my q1 plus q2 plus q3 plus q4, right? So that's how you add multiple number of vectors. Just go on increasing one side of the triangle and you will go on getting your answer. And this is called as polygon law of vectors. Can you please write this down? Please write down. State polygon law of vectors. Please write. State polygon law of vectors. State polygon law of vectors. Leave space for copying this. Write the law down first. Right. If a number of vectors are represented in magnitude and direction, by the sides of an incomplete polygon, taken in order, their resultant is represented in magnitude and direction. By the remaining side of the polygon. Directed from the starting point. Directed from the starting point of the first vector. To the end point of last vector. Directed from the starting point of first vector to the end point of last vector. So that was that polygon law of vectors that I just showed you. Subtraction of vectors. Guys, I had explained this also to you in the last lecture. If I have two vectors, say C vector and D vector, and I want to subtract the two vectors, how do I subtract the two vectors? First draw C vector as it is. Change the direction of D vector and connect it to the end point of C vector. Change the direction of D vector and connect it to the end point of C vector. Since I've changed the direction, the arrow was upward, I'm bringing the arrow downward, this becomes minus D vector. So when I complete the triangle, this will be C vector minus D vector. That's how you subtract two vectors. So this was subtraction of vectors, right? Next, The next thing we had seen last lecture is what is unit vector. I'll explain this to you that what is unit vector. A unit vector is defined as a vector having unit magnitude. A vector having unit magnitude. Unit magnitude means its magnitude is 1. A vector whose magnitude is 1 is called as a unit vector. For example, guys, suppose if I have this vector A. Suppose I have A vector. Now if I want to find out unit vector will be a vector which will be in the same direction, but its magnitude will be 1. So what is unit vector? It is a vector which is in the same direction of the given vector, but its magnitude is 1. Right? How do I find out unit vector? Unit vector is given by the formula. Unit vector is given by the formula A vector divided by magnitude of A vector. So if I divide a given vector by its magnitude, then what I get is called as unit vector. Fine, do we get this thing clear? Now in unit vector you have a couple of other things. Suppose if I have 3 axes. If I have unit vector along say x axis. Unit vector along x axis is called as I vector. Henceforth, whenever I want to say unit vector along x axis, I will call that as I vector. Unit vector along y axis is called as j vector. And unit vector along z axis is called as k vector. So I, j and k are unit vectors along x, y and z axis. Fine, do we get this in here? So what is I, j, k? These are unit vector which are along x axis, y axis and z axis. Fine, do we understand what is unit vector? Next, resolution of vector. So far we were seeing how to add 2 vectors to get one resultant vector. Suppose if they give me a vector, I want to find out what is this vector made up of. Suppose if they give me a vector, say R vector. I want to know what is this vector made up of. What is the x component in this vector and what is the y component of this vector. That process that will enable me to find out what is the x component and y component of a given vector. If there is a z component, that also is called as resolution of vector. What is resolution of vector? It is the process of splitting a given vector into its components, right? Resolution of vectors. Let's first write the definition down, guys. What is resolution of vectors? I'll just write the definition down. It is the process of splitting a given vector into its components, constituent components or into its components. Components means what is the x component in it and what is the y component in it. Right? Do we get this in here? Now, how do I resolve a vector? Resolve the vector means how do I split a vector? Henceforth, instead of using the word split a vector, I'll be using the word resolve a vector. So this is that same given R vector. Draw a vector along x-axis from the starting point. Draw a vector along y-axis from the starting point of the given vector. Fine, do we get this? So if this is O, right? Draw a vector along x-axis, draw a vector along y-axis. From the given vector, drop a perpendicular on the x-axis. This is my x-axis, right? This vector from here to the point where you dropped a perpendicular, that will be your x component of the given vector. So your R vector is going to be made up of this x component. So its x component will be called as Rx. Similarly, when I drop a perpendicular on the y-axis, this is my y-axis, I will get this. This is going to be my Ry. So this is going to be my y component. In simple language, if I want to resolve a vector, let the given vector be the diagonal of a rectangle. Right? Complete the rectangle. The 2 sides that I get will be the x component and the y component of a given vector. Here, I can say that R vector is equal to Rx vector plus Ry vector. R vector is equal to Rx vector plus Ry vector. So thus a given vector can be resolved into two components. Right? Do we get this thing clear? Now since Rx vector is along x axis and Ry vector is along y axis, I can even say that R vector is Rx I vector plus Ry j vector. You will see here I am not putting the vector sign on Rx and Ry. So here Rx and Ry will represent the magnitude and x I vector and j vector will represent its direction along x axis and y axis. So do you understand how do we resolve a vector? A vector can be resolved into two components, along x axis and along y axis, such that it will make an angle of theta with the positive direction x axis. Right? So in that case, suppose if I want to find out x component, how do I find this? We know that opposite sides of a rectangle are congruent. That means if this is Ry, this will also be Ry. Right? Now, I can say that in the given triangle, I can find out cos theta. Cos theta is adjacent upon hypo. Cos theta is adjacent upon hypo. Therefore, I can say Rx vector is equal to R cos theta. So the adjacent, the x component can be found out as R cos theta, and the vertical component, we will just find this out first, sin theta is nothing but Ry upon R. Sin theta is nothing but Ry upon R. Thus I can say that Ry vector is equal to R sin theta. Right? So the horizontal component will be R cos theta and the vertical component will be R sin theta. This is how you resolve a vector along horizontal and vertical, and that's how you mathematically find out those values. Fine, do we get this in clear? Next. Now so far we've seen addition of two vectors, we've seen subtraction of two vectors. Now we'll see the most important thing, multiplication of two vectors. How do I multiply two vectors? There are two methods of multiplying two vectors. Right? Let us see multiplication of vectors. Now when you multiply two vectors, guys, you can multiply two vectors in two methods. One is called as the scalar product. One is called as the vector product. Right? Vector product is also called as the cross product. And scalar product is also called as the dot product. So you can multiply two vectors in such a way that you can have their dot product or cross product. Both are methods of multiplication of two vectors. Now observe this very carefully, you have this in detail. Right? How do I multiply, or what is the difference between them? What is scalar product? Now we know that a vector is made up of magnitude as well as direction. A vector is made up of magnitude as well as direction. If I multiply two vectors in such a way that I multiply only their magnitudes but not their direction, then that is called as scalar product. What is scalar product or dot product? It is the multiplication of two vectors in such a way that you multiply only their magnitudes but not their direction. What is cross product? Cross product or vector product is the multiplication of two vectors in such a way that you not only multiply their magnitude but you also multiply their direction. So if I have two vectors and if I am multiplying only their magnitude, then it is called as dot product. If I have two vectors such that I am multiplying the magnitude as well as direction, then that is called as cross product. Fine, do we get this thing clear? So vectors can be multiplied in two ways. Either I multiply only their magnitude or I multiply their magnitude and direction. Right? So do you understand basically what is a dot product and what is a cross product? Now let's assume that I have two vectors, A vector and B vector. And if I have an angle theta between them, how do I multiply these two vectors such that I multiply only their magnitudes? A vector dot B vector, it is written as dot. If I want to multiply the two vectors such that I multiply only their magnitude, A vector dot B vector is AB cos theta. If I take the magnitude of A, if I take the magnitude of B, and if I take the cos of the angle between them, then what I get is dot product. What I get is just the multiplication of the magnitude of the two vectors. So what is A vector dot B vector? A vector dot B vector is nothing but AB cos theta. Now let us try to study this in detail. Let us see the properties of dot product, right? First, so this is dot product. Let us see the properties of dot product. First property, dot products obey commutative law. What do you mean by dot products obey commutative law? Dot products obey commutative law means A vector dot B vector is equal to B vector dot A vector. Whatever vector I write first or I write later does not make a difference. That is called as commutative law. So dot products obey commutative law. Question. So why do they obey commutative law? Because what is dot product? Dot product is only a number. There is no direction involved in it. Since there is no direction involved in it, therefore they obey commutative law. Fine, do you understand this? Why they obey commutative law? Next, dot products obey distributive law. Distributive law. Right? Distributive law means, suppose if I have A vector dot B vector plus C vector, this will be nothing but A vector dot B vector plus A vector dot C vector. That means when I open the bracket, I can multiply A vector with both the terms. Right? So they obey distributive law. This is called as distributive law. I can open the bracket and multiply them algebraically. I can use my mathematical operations on them. Fine, do we get this thing here? Next, if two vectors are perpendicular to each other, what happens if the two vectors are perpendicular to each other? Right? If the two vectors are perpendicular to each other, suppose let's assume I have P vector is perpendicular to Q vector. If P vector is perpendicular to Q vector, then theta will be equal to 90 degree. Perpendicular means the angle between them has to be 90 degree. Now in that case, what will be P vector dot Q vector? P vector dot Q vector will be PQ cos theta. So that will be PQ cos 90. But we know that cos 90 is 0. So that means if two vectors are perpendicular to each other, their dot product is 0. So if two vectors are perpendicular to each other, their dot product is 0. Is 0. Right? That's the next property. If two vectors are perpendicular to each other, their dot product is 0. And I've shown you why the dot product is 0. Because dot product is AB cos theta. Theta is 90, cos of 90 is 0. Hence the dot product is 0. Anything multiplied by 0 is 0. Next, if two vectors are parallel to each other. If two vectors are parallel to each other, then let us assume that if P vector is parallel to Q vector. If P vector is parallel to Q vector, then what will be the angle between them? What is the angle between two parallel lines? There is no angle. The angle is 0. So in that case, what will be P vector dot Q vector? It will be PQ cos theta. This will be PQ cos of 0. Cos of 0 is 1, so that will be PQ. So if two vectors are parallel to each other, their dot product is the product of their magnitudes. Fine? Now, if we have understood this, we should be able to find out what will be I vector dot I vector. What will be I vector dot I vector? I vector dot I vector. What is I vector? Guys, I just explained to you that I vector is unit vector along x-axis. I vector is unit vector along x-axis. That means its magnitude is going to be 1. Now if I am taking I vector dot I vector, what will be the angle between them? 0. Because if I have two similar vectors, the angle between them is obviously going to be 0. So I vector dot I vector will be equal to 1. I vector dot I vector will be 1 into cos of 0. Cos of 0 is 1. So it will be 1 into 1 into 1, that will be 1. Similarly, J vector dot J vector will also be 1. What is J vector? It is unit vector along y-axis. Similarly, K vector dot K vector will also be equal to 1. Hence, I can say that I vector dot I vector is equal to J vector dot J vector is equal to K vector dot K vector is equal to 1. Similarly, what will be I vector dot J vector? Now, what is I vector and J vector? I vector is unit vector along x-axis, J vector is unit vector along y-axis. What is the angle between x-axis and y-axis? 90 degree. And we just said that if the angle between two vectors is 90, then the product is going to be 0. So I vector dot J vector is going to be 0. Similarly, J vector dot K vector. What is J vector? Unit vector along y-axis. What is K vector? Unit vector along z-axis. Right? Y-axis and z-axis are perpendicular to each other. The angle between them is 90. X, Y, Z, all three vectors are perpendicular to each other, guys. So z-axis is perpendicular to y-axis. Since the angle is 90, their product will be 0. Similarly, what will be K vector dot I vector? K vector dot I vector, again, K vector is unit vector along z-axis, I vector is unit vector along x-axis. The two vectors are perpendicular to each other, so that will be 0. Hence, I can say that I vector dot J vector is equal to J vector dot K vector is equal to K vector dot I vector is equal to 0. Right? Now, suppose if I had two vectors, suppose if I had A vector such that A vector was AX I vector plus AY J vector plus AZ K vector, and I had B vector which was BX I vector plus BY J vector plus BZ K vector. Now suppose if I want to find out the dot product of two vectors, A vector dot B vector. How do I find out the dot product of two vectors? What is dot product, people? Dot product is nothing but the multiplication of the magnitudes of the two vectors. Right? So in that case, this will be nothing but AX BX plus AY BY plus AZ BZ. That's how you multiply the two vectors. So A vector dot B vector will be AX BX plus AY BY plus AZ BZ. There will be no I, J, K. That means the answer that I'm going to get here is going to be a scalar product. It will be a scalar number. It will just be a number without any direction. Fine, do you get this thing clear? So do you understand the properties of dot product? Now let us move on to cross product. Suppose if I have two vectors, I have A vector, I have B vector, and the angle between them is theta. Right? I had already explained to you what is cross product. Cross product is multiplication of two vectors in such a way that you not only multiply their magnitude but also their direction. So A vector cross B vector will be nothing but AB sin theta. By definition, how do you multiply two vectors such that you multiply their magnitude and direction? So what is A vector cross B vector? It is nothing but the magnitude of two vectors and the sign of the angle between them. Right? Now let us see the properties of cross product. What are the properties of cross product? Right? First thing, they do not obey commutative law. Do not obey commutative law. That means A vector dot B vector is not equal, A vector cross B vector is not equal to B vector cross A vector. Why? Because very simple guys, if you have direction involved in it, then how can they be equal? Right? If you have direction involved, if you change the direction, how can two vectors be equal? Right? I can say therefore that A vector cross B vector is equal to minus B vector cross A vector. Since you are changing the direction, you have to put a minus sign. Remember we had used this principle even while subtraction of vectors, right? If you change the direction, then you have to put minus sign. Fine, do we get this? So, cross product does not obey the commutative law. Next, it obeys the distributive law. What is the distributive law? That means if I have A vector cross B vector plus C vector, this will be nothing but A vector cross B vector plus A vector cross C vector. That means I can open the bracket and mathematically or algebraically just multiply the two terms. So it obeys the distributive law. Fine, do we get this in here? Next, if two vectors are perpendicular to each other, what happens if the two vectors are perpendicular to each other? Suppose if I have P vector is perpendicular to Q vector. Now if P vector is perpendicular to Q vector, then theta will be equal to 90 degree. If P vector is perpendicular to Q vector, then theta will be equal to 90 degree. In that case, what will be P vector cross Q vector? We just said that cross product of two vectors is nothing but the magnitude of two vectors and the sign of the angle between them. So it will be PQ sin theta, that will be PQ sin 90, sin of 90 is 1, so it will be PQ. So if two vectors are perpendicular to each other, their cross product will be equal to the product of the two vectors. P vector cross Q vector will be nothing but magnitude of P into magnitude of Q. Next, if two vectors are parallel to each other, if two vectors are parallel to each other, that means if P vector is parallel to Q vector, if two vectors are parallel to each other, then the angle between them will be 0 degrees. So in that case, P vector cross Q vector will be nothing but PQ sin theta. So that will be PQ sin of 0. Sin of 0 is 0. So P vector cross Q vector will be nothing but 0. So if two vectors are parallel to each other, their cross product is 0. Right? Now, on that basis, I should be able to say this. What is I vector dot I vector? I vector dot I vector. What is the angle between I vector and I vector? 0. If the angle between them is 0, that means they are parallel to each other. I just explained to you that if two vectors are parallel to each other, sorry, this should be cross, their cross product will be 0. So I vector cross I vector is going to be 0. Similarly, I can say J vector cross J vector will be 0 and K vector cross K vector will also be equal to 0. The two vectors are going to be parallel to each other, therefore their cross product is going to be equal to 0. Similarly, what will be I vector cross J vector? Now guys, see this. I have X axis, Y axis, Z axis. The cross product of two vectors is always a third vector such that the third vector is perpendicular to both the vectors. The cross product of two vectors is always a third vector such that the third vector is perpendicular to these two vectors. Now if I am taking I and J, which is the only axis that is perpendicular to X axis and Y axis, the Z axis. So I vector cross J vector will be nothing but K vector. Similarly, J vector cross K vector will be nothing but I vector. Right? And IJ, JK. K vector cross I vector will be equal to J vector. Right? So the cross product of two vectors is going to be a third vector such that it is perpendicular to the two vectors. Right? Now, suppose if I have two vectors, suppose if I have A vector such that it is AX I vector plus ayj vector plus azk vector. Similarly, I have b vector which is bxi vector plus byj vector plus bzk vector. How do I find the cross product of two vectors? Now you all have in 10th standard, I presume, learned determinants. What will be a vector cross b vector? How do I find out a vector cross b vector? Guys, what you have to do is first write the three axes down. Guys, see this. I, j, k. Right? Then write the magnitudes of the first vector. Ax, ay, az. Then write the magnitudes of the second vector. Bx, by and bz. Right? So by using determinants, you can find out the cross product of two vectors. I'll tell you how this will be. This is going to be I vector. Now if I take I vector, I cannot take this column and this particular row. How do you do determinants? It is product of the principal diagonal minus the other diagonal. Meaning this will be ay bz minus by az. Minus. Why minus? Guys, that's a part of the formula. Minus j vector. I cannot take the first row and the second column. So this will be ax bz plus minus bx az plus k vector. Why plus? Again, that's a part of the formula. If I take k vector, I cannot take the first row and the third column. So this will be ax by plus bx ay. Right? That will be the cross product of two vectors. Right? This finishes the theory of this chapter. We will stop this here for the day. Thank you very much.